The purpose of this video is to discuss how to predict products for precipitation reactions. Precipitation reactions are double replacement reactions that produce solid products. That product is called a precipitate. Now, it's not just one product, it also produces a supernatant. And so if you look at this reaction, sodium chloride plus silver nitrate yields silver chloride plus sodium nitrate. We have 1, 2, 3 aqueous solutions. Your two reactants are aqueous. One product is solid, that's the precipitate. The other product is aqueous, that's called the supernatant. The yellow part in this example is the precipitate. The clear part is the supernatant. These are represented with different types of equations. One is the molecular equation, which is not the most accurate because silver nitrate is aqueous. That means that silver and nitrate ions dissociate out of silver nitrate. So you have solid sodium nitrate, but you put it in water, it dissociates into ions. The same is true for sodium chloride and sodium nitrate. A more accurate representation is called the ionic equation. So silver nitrate is composed of silver and nitrate ions. Sodium chloride is composed of sodium and chloride ions. Silver chloride is solid, so we keep that the same. But sodium nitrate is composed of sodium and nitrate ions. Now this is a lot, right? So we also have the net ionic equation, which only shows the ions that form your precipitate. So if you can identify the precipitate, you look at it and see which ions form that precipitate, and you write the formula, or you write the equation based off of that. So this is how you do it. Start off with the molecular equation. And notice that I highlighted each aqueous solution because we're going to write the product of dissolution for each. So first is silver nitrate. Silver nitrate dissociates into silver and nitrate ions. Sodium chloride dissociates into sodium and chloride ions. Sodium nitrate dissociates into sodium and nitrate ions. But remember, the precipitate did not dissociate, so we write that as a molecular or like a regular formula, right? We're not going to write an ionic version because it's solid. It did not dissociate into ions. So when we write the ionic equation, we write the ions for each one of those substances, with the precipitate remaining the same. You don't change the precipitate. Now, how about the net ionic equation? Well, you use the ionic equation, but we only focus on the precipitate. So anything that is not the precipitate or doesn't form, those are called spectator ions, and we don't write those. So we get rid of those. And then see right here in the middle, we get rid of those. That leaves you with silver chloride and silver chloride. So the net ionic equation, silver ions plus chloride ions yield silver chloride. Now, how do you predict which substances will be aqueous and which ones will be solid? Solubility rules. Silver nitrate. So we look over here. Do we see silver? Do we see nitrate? Oh, there's nitrate right there. It's soluble with no exceptions. Aqueous. Soluble is aqueous. How about sodium chloride? Well, I see sodium and I see chloride, both soluble, soluble. Sodium, no exceptions. Chloride is insoluble with silver, but sodium is not silver. So it is soluble, which means aqueous. Next is silver chloride. So I have chloride right here. It's soluble, but silver is an exception. So it's soluble unless it's bonded to silver. Well, guess what? It's bonded to silver, right? So instead of being soluble, it's insoluble. Insoluble is solid. Sodium nitrate. Sodium nitrate, both soluble, no exceptions, aqueous solution. Okay, hopefully that helps.